Hi guys, tonight's topic is the pH scale in acids and bases. So water is composed of equal amounts of hydrogen ions and hydroxide ions. So the hydrogen ions are the H+, hydroxide ions are OH negative. And so when a molecule of H2O, that's water, right, breaks apart, you get one of these and one of these. So that's equal concentrations. And so acidity is a measure of the relative amounts of these two ions in solution. And because water contains equal numbers of hydrogen and hydroxide ions, water is neutral. And so you find it on the pH scale right in the middle at 7, where there's equal amounts, 10 to the negative 7, of hydroxide and hydrogen ions in solution. Ionic compounds dissociate or break apart when they're dissolved in water, and that's because the charged ends of the water molecule are attracted to the charged ions of the ionic compound. So how susceptible the substance is to breaking apart depends on the strength of the ionic bonds holding it together. Table salt is totally able to break apart in water. So acids are substances that dissociate to release hydrogen ions into solution. So H+ ions, hydrogen ions. So when hydrochloric acid is dissolved in water, it completely dissociates to form hydrogen ions and chlorine ions. Bases are substances that produce hydroxide ions when dissolved in water. Sodium hydroxide is a common base. In it, when it dissociates, forms hydroxide ions along with sodium. pH is a measure of the acidity of a solution. So the pH scale, as you see on here, it ranges from 0 to 14. You usually don't find much that's less than 1, though, on the scale. pH below 7, so in this range, 0 to 7, means that a substance is acidic, and increasingly acidic as you go from 7 to 0. Above a pH of 7, from 7 to 14, gets increasingly more basic. Another word for basic is alkaline. So this scale is a logarithmic scale. So the formula for it is that the pH equals the negative log of the hydrogen ions. You can also find it the opposite way by if you only know the concentration of the hydroxide ions, because the concentration of the two is always going to equal 14. So if you look across the scale, you see that if the hydrogen ions are 10 to the negative 12, the hydroxide ions are 10 to the negative 2. So if you just take the exponent, that's all we're really interested in. 2 plus 12 equals 14. On the other end, let's see here at a pH of 3, you've got 10 to the negative 3 for the hydrogen ions, 10 to the negative 11 for hydroxide ions, 3 plus 11, again, equals 14. So you can always figure out, whichever one you're given, what the pH is. So if you're given the hydrogen ion concentration, just look at the exponent, and that's exactly equal to the pH. If you're given the hydroxide ion concentration, you need to take that number and subtract it from 14. So right here, you have 10 to the negative 13, so you take 13, subtract it from 14, and you get a pH of 1. So there's some practice that you can do for that on your sheet. And the important thing to remember here is that with a logarithmic scale, every step you go, it's changing by 10 times. So if something is 2 numbers different on the pH scale, like if we go from pH from 5 to 3, that's 100 times more acidic. If we go just from 5 to 4, that's 10 times more acidic. If we were to go from 5 to 2, that's 1,000 times more acidic. So that's something to get used to there. Give a little practice on that. And then another thing that's important is that there's some substances that can resist big changes in pH, and those substances are called buffers. And we're going to talk about those a little more in class and get some practice with all this cool pH stuff tomorrow. So stay tuned. Have a good night.